So let us now see what the marginal distribution of x is. So recall that the marginal distribution is simply the distribution of x if you ignore the value of y. Okay, and so again, you notice that x ranges from -1, 1, just like we had in example 1, right? But now this is not uniform, right? So the distribution is not uniform. Because intuitively you can imagine if I want x to be, I'm picking a point uniformly at random in this square, in the square. So if I want x to be, let's say, very close to -1, then I need that uniformly random point to be somewhere in this neighborhood. But if I want x to be pretty close to 0, then I want my uniformly random point to be in this rectangle, that is in this pretty long strip. Right? So you observe right away that the probability that, at least intuitively, the probability that x equals ±1 is much smaller than the probability that x equals 0. Okay, or at least the density functions must be much smaller. PDF values must be smaller. Okay, so now let's see how you formally compute this. Okay, so what you observe is that, so let's see how you compute. So this is P sub x. This is our notation for the marginal distribution. Okay, so let's see how you would evaluate P sub s of x. Okay, so this is the probability that x takes the value that is equal to s, or since it's a continuous distribution, it just means that what is the density at value x equals s. Okay, so clearly, so this must be proportional to this height, right? So if I look at this square and I take a certain value s, right? So this is x equals 0, and the value of this density function must be proportional to this height. Okay, so what is this height? So this height is exactly equal to 1 minus absolute value of s. So why absolute value? Because if I take s equals let's say minus half, okay, so the height is not negative, right? So the height is still 1 minus absolute value of s. So what we know is that this is proportional to 1 minus absolute value of s. Okay, so what does that mean? So it's 1 minus absolute value of s divided by a normalizing factor. So what should that normalization factor be? It should just be the integral from -1 to 1 of this, or of the numerator, right? Because having this normalization ensures that the probability values add up to 1. Okay, so now this it's an exercise for you to know, to compute that the integral evaluates to 1. Okay, so the denominator of this turns out to be equal to 1, and therefore the numerator is what remains, and this turns out to be exactly 1 minus absolute value of s. Okay, So this is what we have. These are the values of the conditional distribution of y given certain x's, and this is the marginal distribution of x. Okay. You can also derive the marginal distribution by using the formula for it, which we saw before. So the marginal distribution of x. So you can also use the formula that we had derived. Okay. So yeah, so if it seems complicated, so let me just write it out, so I don't seem to be able to find it. So the marginal distribution is just px of s is simply the integral over all t of px y of s t dt. Okay, because this is how we define the marginal probability, right? So we were looking at we were fixing the row and adding up all the entries in the row. And this is a continuous random variable, so instead of adding up we are integrating. So this is what we are doing, and you can note that if you that in our case this p is actually a uniform distribution, so it's actually a constant, so you just get the length of this range, and t goes from ideally it goes from minus infinity to infinity, but p is 0 unless you are in this interval, right? So this is t should go from minus of 1 minus mod s to 1 minus absolute value of s, right? Because in this picture, if you fix x equals s, then anywhere out here the pxy value is 0, and over here the pxy value is uniform. Okay, so this is why you get something that's proportional to this length. Okay, so this is a formal way of seeing the same thing. Alright, and this also of course gives the same answer. So this is 1 minus absolute value of s. Okay, so this value turns out to be half. So that's how you end up getting this 1 minus absolute value of s. Okay, so if you don't see this right away, this is an exercise that you should work out and make sure you understand this way of deriving this also. Okay, so this completes this example of looking at marginal distributions.